Hello students, welcome to Yupp Master. This is 11th class IIT Live. I am Radha Krishna, mathematics teacher. Today we are going to discuss some very important chapter in IIT JEE mathematics, that is sequences and series. Let us start the session. First of all, what is a sequence and what is a series? What is a progression? Many of you, even teachers, are not aware of the correct definition of the sequence, series and progression. Now let us see what is a sequence, what is a series, what is a progression, right? First, definition of sequence: a set of numbers which are arranged according to a specific rule is called a sequence. This specific rule can be a mathematical rule or a logical rule. You please understand what is a mathematical rule, what is logical rule. You are going to understand from the examples. Let us take some examples. In the first example, I have taken the series, I have taken the numbers 1, 3, 5, 7 and so on. What is the common rule applied in this numbers? The first number is 1. Adding 2 to the first number, you are getting the second number 3. Again adding 2, you are getting the third number. Third number plus 2 is fourth number. So every term is obtained by adding 2 to the preceding term. So the mathematical formula is, mathematical rule is adding 3. Adding 3 means addition of 3, addition of 2 is a mathematical rule. So this is a sequence, it is following a mathematical rule. Alright. Now let us take the next example. The numbers are 2, 6, 18, 54 and so on. What can you notice? Every term is multiplied by 3. It becomes the second term, next term. 2 into 3 is 6, 6 into 3 is 18, 18 into 3 is 54 and so on. So here common property is, common mathematical rule is multiplication by 3. Okay, so this is a sequence. Next, 2, 3, 5, 7, 11 and so on. Can anyone tell the property used? You cannot tell any mathematical rule because they are all prime numbers. 2, 3, 5, 7, 11 all are prime numbers. So I have written the set of prime numbers in increasing order. So there is a common property which cannot be mathematically expressed. So that is called logical rule. So all these rules, all these numbers are called sequences. The list of numbers are called sequences arranged in order. But if you jumble the numbers, it won't be a sequence, is it not? There should be a common rule, common logical rule or common mathematical rule. Alright. Now let us see what is a series. A series, if a sequence of numbers is connected by plus sign or minus sign, it is called a series. So if you take 2 plus 3 plus 5 plus 11 and so on, it is called a series. Sum of the numbers in the sequence is called a series. Okay, and the next is 1 square plus 2 square plus 3 square and so on. This is called a series. Okay, sum of the numbers in the sequence is called a series. And you can also use minus sign. 1 minus 2 plus 3 minus 4, alternately we have used plus sign and minus sign. This is also a series. Now what is a progression? A set of numbers which are arranged according to a definite mathematical rule is called a progression. Earlier in sequences we have seen 3 examples. In these 3, among these 3, first one and second one are following the mathematical rule. They are called progressions. This is not a progression. Understood? So a set of numbers which are arranged according to a definite mathematical rule is called a progression. So let us see the examples. 1, 4, 7, 10 and so on. What is the mathematical rule? Addition of 3. 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10 and so on. In the second example, 1, 3, 9, 27 and so on. You can easily identify the mathematical rule. Multiplication by 3. 1 into 3 is 3, 3 into 3 is 9, 9 into 3 is 27 and so on. Okay. Next is 1 by 2, 1 by 5, 1 by 8, 1 by 11 and so on. Here all numerators are same 1 and denominators are following a mathematical rule. What is addition by 3? 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. So you will be able to tell the next one as 1 by 11 plus 3, 1 by 14. So these three are the examples for a progression. Now a very important note is the difference between a progression and a sequence is that a progression has a specific formula to calculate its nth term, whereas a sequence may not have such formula. So you can easily understand what is the difference between a sequence and a progression. In progression, there will be a mathematical formula to calculate the nth term. If you cannot tell any mathematical formula for the nth term, then that is only a sequence, not a progression. Every progression is a sequence, but every sequence may not be a progression. I hope it is very clear. Now let us discuss some basic progressions. Basic progressions are arithmetic progression, geometric progression and harmonic progression. Among them I am going to discuss arithmetic progression in today's class. Alright. Arithmetic progression, usually we say it is AP. A set of numbers which are arranged such that every number exceeds the preceding number by a constant is called an AP. We have seen some examples where every term is some preceding term plus some constant. That kind of terms form an arithmetic progression. And the constant which is being added to every term for getting the next term is called common difference of the AP. Okay. Now let us see the example. In the progression 2, 5, 8, 11 and so on. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11 and so on. That 3 which is being added is called common difference. So in further classes I will write it as CD, common difference. Alright. Now let us know how to write a general arithmetic progression. If we take the first term as A and the common difference as D, then the AP is first term A, first term plus common difference, A plus D is second term, A plus 2D is third term, again adding D, A plus 3D and so on. You can continue till any number of terms. Now by observing the pattern followed by the terms, you can write the nth term. Nth term is denoted by Tn. That means this is T1, this is T2, T3 and so on. So if you observe the patterns, in second term there is 1D added to A. In the third term there are 2 Ds added to A. In the fourth term 3 Ds are added to A. So in nth term we have to add n minus 1 Ds to A. So this is the formula for nth term of an AP. Now sum of the first n terms of the AP, that is A plus D plus A plus 2D plus A plus 3D and so on, is equal to n by 2 into 2A plus n minus 1 to D. Quickly I will explain the proof also. The sum of the n terms of the AP is A plus D plus A plus 2D and so on till A plus n minus 1 into d, which is nth term. I have written the first n terms of the arithmetic progression. Now I want the sum of the n terms denoted by Sn. Sum of n terms of any series is denoted by Sn, capital S suffix n, right. Now let us write the same series backwards. So last term becomes first term, comes here, a plus n minus 1 into d plus what is the second last term? From left to right, d is being added to every term. If you write from right to left, d should be subtracted from every term. So this minus d will be a plus n minus 2 into d. Next term, again subtract another d, a plus n minus 3 into d, and so on. This first term a becomes last term plus a. Now if you add the two series, Sn plus Sn is 2Sn, first term plus first term, what will you get? 2a plus n minus 1 into d. Again second term plus second term is also same, 2a plus n minus 1 into d. Third plus third is also 2a plus n minus 1 into d, alright. And how many terms will be there like this? Since there are n terms here and n terms here, there will be n times 2a plus n minus 1 into d repeated. So it will be, the sum of these n terms will be n into 2a plus n minus 1 into d, alright. Now Sn is dividing both sides by 2, you will get n by 2 into 2a plus n minus 1 into d, alright. So this is how we got this formula. Now in this formula, if you separate a here, remaining a plus n minus 1 into d is nothing but Tn, means last term. If you denote the last term by L, you can write the same formula as n by 2 into a plus L, first term plus last term, alright. So you can remember the formula in this way or in this way. And it is also n into middle term, when only when n is odd. If you take the AP as T1, T2, T3, T1 plus T2 plus T3 plus and so on Tn. You have to remember that the first term plus last term of the AP will be equal to the middle term of the AP. But when will you get the middle term? Only when number of terms is odd. When n is odd, you will have exactly one middle term. When n is even, it can be separated into two equal halves, there is nothing left in the middle, is it not? So if n is odd, there will be one middle term. That middle term is average of the first and last terms. T1 plus T2 by 2 will be the middle term. Average of, all of you know the average is sum of the numbers by 2. Average of the first and last terms of any AP will be equal to the middle term only when n is odd. So here a plus L is first term plus last term by 2 will be the middle term of the AP when n is odd. So you can also remember the formula as n into middle term when n is odd, alright. Now let us discuss some properties of AP. The first point, if A, B, C are in AP, what does it mean? A, B, C are consecutive terms of the AP, not any terms. Then the difference between A and B should be equal to difference between B and C. Then B minus A will be equal to C minus B. Then you can write it as 2B is equal to A plus C. Then B is equal to A plus C by 2. Okay. So, if ABC are said to be in AP, sometimes we write this, sometimes we write this, sometimes we write this, depending on the question. Only for calculation sake we write different forms, all are same. And one more point, this B is equal to A plus C by 2, the middle one is called arithmetic mean of A and C. Okay, let us discuss the arithmetic mean and other points later in another class. Today we are going to focus on only AP. Okay, arithmetic mean and other means will be discussed later. Right. Now next property of AP is, if ABC are in AP, then A plus K, B plus K, C plus K are also in AP. That means by adding a fixed number K to every term of an AP, the resulting series will be again AP. Similarly, if you subtract K from every term, A minus K, B minus K, C minus K will also be in AP, because by subtracting or adding, the difference won't change. This second term minus first term is B minus A, that is common difference of this AP, and third term minus second term is C minus B, that is also common difference of this AP. Okay. Next, if you multiply every term by K, KA, KB, KC, they will be in AP again. Here what happens, if ABC are in AP, B minus A is equal to C minus B, which is equal to common difference D, say. Then this second term minus first term is K into B minus A, that is KD. Third term minus second term is what? K into C minus B, that is also KD. So, difference between first and second is equal to difference between second and third. That means it is AP, but common difference will change. So, if every term of an arithmetic progression is multiplied by a fixed number, then the resulting series will be arithmetic progression. Next, if you divide every term by K, a fixed number, then also the resulting numbers will form arithmetic progression. Alright. Now another very important property of an arithmetic progression is, if T1, T2, T3 and so on Tn are in arithmetic progression, a very important property is first term plus last term will be equal to second term from left and second term from right. Second term from left plus second term from right will be equal to third term from left plus third term from right. So, sum of the terms equidistant from left and right in any arithmetic progression will be same. So, T1 plus Tn will be equal to T2 plus Tn minus 1, second from last, is equal to T3 plus Tn minus 2, third term from left plus third term from right, and so on. This is very useful in calculations in this chapter. Okay. So, this is about nth term, sum of the nth terms, and also properties of AP. Now, let us start few problems on AP, right. First problem, if the sum of the first n terms of an AP is 2n square minus 3n, then find the 10th term. Very simple question. Sum of the n terms means T1 plus T2 plus T3 and so on up to Tn. You will denote it by Sn. Sn is given as 2n square minus 3n. Right. Now, you find Sn minus 1. What is it? It is sum of the first n minus 1 terms, T1 plus T2 plus T3 and so on till Tn minus 1. by replacing n by n minus 1, 2 into n minus 1 whole square minus 3 into n minus 1. Sn is sum from T1 to Tn, Sn minus 1 is sum from T1 to Tn minus 1. So Tn is extra in Sn. So if you subtract Sn minus 1 from Sn, what will you get? Tn. Tn, nth term Tn will be given by Sn minus Sn minus 1. Not only for AP, for any progression, nth term is given by Sn minus Sn minus 1. Alright. Now, subtracting these two, 2 is common. 2 into n square minus of n minus 1 whole square minus 3 into n minus of n minus 1. Alright. Now, let us simplify by using the formula a square minus b square is equal to a plus b into a minus b. You will get 2 into a plus b is n plus n minus 1, 2n minus 1 into a minus b is n minus of n minus 1, 1 minus 3 into n minus of n minus 1 is 1. So, 3 into 1 is 3. Then it is 2 into 2n, 4n minus 2 minus 3 is minus 5. Alright. Now, we got the nth term. What do you want? 10th term. T10 is equal to, putting n is equal to 10, you will get 40 minus 5. What is it? 35. Alright. Let us proceed to next question. It was actually previous JEE question long back. The interior angles of a convex polygon are in AP with common difference 5 degrees. If the smallest angle is 120 degrees, find the number of sides. You must be aware of a polygon. If you take a figure like this, it is called a polygon. How many sides are there? 1, 2, 3, 4, 5, 6. There are 6 sides of this polygon. So, it is called hexagon. Alright. Now, these angles are called interior angles. Angles between the sides which are inside the polygon. They are called interior angles. If each interior angle is less than 180 degrees, it is called convex polygon. If each interior angle of a polygon is less than 180 degrees, it is called convex polygon. Alright. But what if it is not convex? Let us consider another polygon like this. In this polygon, we have 1, 2, 3, 4, 5, 6, again 6 sides, hexagon. But if you look at the interior angles, this is less than 180 degrees, 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 but this is more than 180 degrees. Then this is not convex. Then what it is? It is called concave polygon. Alright. But in the question it is said that it is a convex polygon. So that is the first point you should keep in mind. So every interior angle must be less than 180 degrees. Alright. Now let us start solving the question. Now interior angles are in AP. Smallest angle is 120 degrees, common difference is 5 degrees. So what are the interior angles? 120 degrees is 1 and further adding 5, 125 degrees, 130 degrees and so on. We don't know how many interior angles are there. If there are n sides, then there will be n interior angles. Alright. Now let us calculate the sum of all interior angles in the polygon. First, I will denote the first term of the interior angles, or the smallest interior angle, as A. A is 120 degrees and common difference is 5 degrees. Alright. Let n be the number of sides. Number of sides is equal to number of interior angles, is it not? Alright. Now, I am going to calculate the sum of all interior angles of the polygon. Sum of all the interior angles is equal to sum of the AP, sum of the n terms of the AP. We have the first term, common difference, number of terms. So, what is the formula? N by 2 into 2A plus n minus 1 into D. It is equal to n by 2 into, what is 2A? 2 into 140 degrees, 120 degrees, it is 240 degrees, plus n minus 1 into common difference 5 degrees. And all of you must be aware of one important formula related to polygons. Sum of all interior angles of any polygon is equal to what? N minus 2 times 180 degrees, n minus 2 into pi. Okay, I hope all of you know this formula. So, this sum must be equal to n minus 2 into 180 degrees. Alright. Now onwards, for next step onwards, I am not going to write the units degrees. Okay. So, finally, I have to solve this equation and I have to get the value of n. Units don't matter because both sides same unit. Now, if I divide both sides by 5, because this is divisible by 5, this is divisible by 5, this is also divisible by 5, I will get n by 2 into this divided by 5. How much? 240 divided by 5. 240 divided by 10 is 24, divided by 5 is 48, plus n minus 1 is equal to n minus 2 into 180 divided by 5 will be 72, no, it is 36. 180 divided by 5 is 36. Alright. Now, cross multiply by 2. This will be n into n plus 47, 48 minus 1, 47 is equal to n minus 2 into 2 into 36 is 72. Now, you are going to get a quadratic equation in n. N into n square, n into 47, 47n is equal to 72n minus 144. Alright. Now, n square plus this minus this will be minus 25n. If minus 144 comes left side, it becomes plus 144 equal to 0. Now, if you factorize it, you will get n minus 9 into n minus 16 equal to 0. So, I am not going to explain the method of factorizing and all. So, because all of you must be aware of the basic methods. Now, if n minus 9 into n minus 16 is 0, n is 9 or 16. And you will think that solution is completed, but it is not. Why? Why is it given that the polygon is convex? Every interior angle should be less than 180 degrees. Let us see the angles. Angles are increasing. So, greatest angle is the last angle or nth angle. If the last angle is less than 180 degrees, automatically all remaining angles are less than 180 degrees. So, I will check the greatest angle for n is equal to 9, n is equal to 16. If n is equal to 9, what is the last term? That means Tn. Tn will be a plus n minus 1 into d. That is a is 120 degrees first term plus n, if n is 9, it will be 8 into 5. How much? It will be 160 degrees less than 180. It is okay, allowed. It is a convex polygon. But if you take n is equal to 16, what is the last term? Again same formula, 120 plus 16 minus 1, 15 into 5. How much are you getting? 195 degrees, which is greater than 180. So, this is not a convex polygon. So, the correct answer is 9 only, not 16. Okay. This is the only correct answer. Let us proceed to the next question. A very nice question and very important question this is. How many terms in the following two APs are identical? Two APs are given, 2, 4, 6, 8 and so on up to 100 numbers, and 3, 6, 9, 12 and so on up to 80 numbers. Among the two APs, how many terms are identical? You can call them as common terms. Same question can be given as find the number of common terms in the following two APs. Carefully you follow the method I am going to explain. Identify the first common term. It will be very easy. Here in the first series 6, in the second series second term are common. So, this is the first common term. Alright, write it. Then you need not check the further common terms. These two are two APs. First AP has common difference 2. Here common difference is 2. For second AP common difference is 3. Then the common terms of the two APs will form another AP with common difference, which is the LCM of these two common differences. This is the very important point you need to remember. Alright. So, what is the LCM of 2 and 3? 6. So, if you write an arithmetic progression, another arithmetic progression with first term 6 and common difference 6, which is LCM, then you will be getting the further common terms. Alright. So, first term is 6, common difference is 6 now. So, 6 plus 6, next term is 12, next term is 18, next is 24 and so on. This is the series of common numbers. Right. Now, I want the number of common terms. Now, what is the last term in the first series? First, we cannot call it a series because just it is a list of numbers, not sum. What is the number of terms in the first progression? 100th term you can easily calculate. First term is 2, second term is 4, third term is 6. So, 100th term will be 200. Alright. What is the 80th term of the second series? Second series is what? First term is 3, second term is 6, third term is 9, fourth term is 12. So, you can observe that if 80 is multiplied by 3, you will be getting last term. 80 into 3 is what? 240. So, the first series is 2, 4, 6, 8 and so on 200. Second series is 3, 6, 9, 12 and so on up to 240. We are going to find the common terms. So, common terms should be clearly less than 200. Common term cannot be greater than 200. Is it not? Because this is the highest term in the first progression. So, the last term, suppose there are n common terms, then that nth term must be less than or equal to 200. Is it not? Let the number of common terms be n. Then what is the last term of these common numbers? This is, since this is AP, 6 plus n minus 1 into common difference 6. This must be less than or equal to how much? 200. Then this is 6 plus 6n minus 6 is less than or equal to 200. 6 cancels. Then dividing both sides by 6, we will get n is less than or equal to 200 by 6. What is 200 by 6? 100 by 3. 100 by 3 is 33.333 and so on. Now, we have to find the largest integer n satisfying this inequality. Is it not? Because if you take first term, it is less than 200. Second term is also less than 200. Third term is also less than 200. What is the largest term in this series which is less than 200? So, we have to find the largest value of n satisfying this equation, this inequality. What is the largest value of n? N is a positive integer. If n is less than or equal to 33.33, the largest number n is 33. Therefore, number of common terms is 33. Alright, let us proceed to next question. This is a very simple question. If three numbers are in AP whose sum is 15 and product is 80, find the three numbers in AP whose sum is 15 and product is 80. Usually when three numbers are in AP, we have to take them as A plus D, A plus 2D. If four numbers are there, A plus 2, A plus D, A plus 2D, A plus 3D. But for calculation sake, we take the numbers differently. When three numbers are said to be in arithmetic progression, we take the numbers as A minus D, A plus D. These three are also in AP because difference between these two is D, difference between these two is D. Similarly, if four numbers are in AP, you take the numbers as A minus 3D, A minus D, A plus D, A plus 3D. Then the calculation will be very simple, nothing else. Alright, now let us take the numbers which are in AP as A minus D, A plus D. Now, their sum is 15. What is the sum? If you add these three, D will be cancelled, you will get 3A is equal to how much? 15. So, we are directly getting the middle term. This is the advantage by taking the terms as A minus D, A plus D. Alright. Next, calculation will be simple, that is all. Now the product. If you multiply these three, A minus D into A plus D is 80. Alright. Substitute A here. 5 minus D into 5 plus D is equal to 80. You can cancel 5. 5 is common in LHS and RHS. 5 16s are 80. 5 minus D into 5 plus D is 5 square minus D square, that is 25 minus D square is equal to 16. We will get D square is equal to 9. Then D is equal to plus or minus 3. Alright. Now, if D is equal to 3, what are the numbers? Numbers are A minus D, A plus D, no? The numbers are A is already 5. So, 5 minus 3 means 2, 5 and 5 plus 3, 8. These are the numbers. If D is equal to minus 3, the numbers are A minus D means 5 minus of minus 3, that is 5 plus 3, 8. 8, 5 and A plus D is 5 minus 3, that is 2. In both the cases we are getting the same numbers, but order of the numbers is different. But we should not assume that both are same APs. The series, the progression 258 is different from 852. This progression has common difference 5, common difference 3, this progression has common difference minus 3. Suppose the question is find the number of such APs, then the answer would be 2, not 1. Okay. So, usually students commit mistakes in this kind of silly points. Alright. Let us proceed to next question. Very simple question. If A, B, C are in AP, show that B plus C, C plus A plus B are in AP. If A, B, C are in AP, usually many of you will apply the formula if A, B, C are in AP, 2B is equal to A plus C or B is equal to A plus C by 2. But don't immediately apply that formula. In some problems we definitely apply that formula, but usually we will solve this kind of questions by using the properties. What are the properties? Adding a constant to every term of an AP, it will be an AP. Subtracting any constant, it will be an AP. Multiplying or dividing by a fixed constant, the numbers will be an AP. These are the properties we have discussed. Now, if A, B, C are in AP, I will subtract A plus B plus C from every number. A minus of A plus B plus C, comma, B minus of A plus B plus C, C minus of A plus B plus C are in AP. Because I have subtracted the same number from every term. Now, what is this? A minus of A plus B plus C is minus of B plus C. This is minus of C plus A. This is minus of A plus B. Alright, are in AP. Now what will I do? I will divide all the terms by minus 1. Dividing this by minus 1, I will get B plus C. Dividing this by minus 1, I will get C plus A. Dividing this by minus 1, I will get A plus B. Dividing by a fixed number, the series numbers will be in AP only. So these three are in AP. That's all, it is finished. Okay, let us proceed to next question. It's a very, very important question, important model. All of you carefully listen and remember the method. If the sums of the first n terms of two APs are in the ratio 3n minus 13 is to 5n plus 21, find the ratio of their 24th terms. Very, very, very important question in this chapter, arithmetic progression. We have to consider two APs. Let A1 and A2 be the first terms, and D1 and D2 be the common differences of the two APs. Be the common differences of the two APs. Alright. Now, let us also denote the first sum of the first AP by Sn, sum of the second AP by S dash n. Then ratio of the sums of the n terms is given, so Sn by S dash n. How do you get? Sn is n by 2 into 2a plus n minus 1 into d, 2a1 plus n minus 1 into d1, alright, upon S dash n, n by 2 into 2a2 plus n minus 1 into d2 is given as 3n minus 13 divided by 5n plus 21. Alright, this is given. What do you want? Ratio of the 24th terms. To find ratio of 24th terms is T24 upon T dash 24. Alright. You know what is the nth term of an AP? A plus n minus 1 into d. So, for T24 it is A1 plus 24 minus 1 23 d1 by A2 plus 20 A2 plus 23 d2. Alright. You want this. This is given. Now you observe. N by 2 cancels. Now if you closely observe this and that, we have to derive that value from this. You will easily get the idea what to do. Definitely we have to substitute some value of n to get this result, is it not? What should be that value? Here 2a1, 2a2 are there, but here a1 and a2 are there. If you multiply numerator and denominator by 2, what will you get? This becomes 2a1 plus 46 d1 by 2a2 plus 46 d2. We have multiplied by 2 because you have to derive that using this, because 2a1 and 2a2 are here in the numerator first terms. Now if you observe that and this, you can easily get the idea what to do, what to substitute in place of n. If you substitute n is equal to 47, this becomes exactly that. So put n is equal to 47, then this becomes 2a1 plus 46, 2a1 plus 46d1 by 2a2 plus 46d2. You have to put for n is equal to 47 in the RHS also. 3 into 47 is 141 minus 13 by 5 into 47. If you calculate, you will get 235 plus 21. 141 minus 13 is 128 upon 235 minus 50 plus 51 is 235 plus 21 is 256. Then what it is? 128 divided by 256, it is 1 by 2. So ratio of 24th terms is 1 by 2, means 1 is to 2. 24th terms are in the ratio 1 is to 2. All right. Now let us take up the next question and the last question probably. The first term of an AP with even number of terms is unity. First term is 1, number of terms is even. All right. If the ratio of the sum of the first half to the sum of the second half is a constant, then find the common difference of the AP. Very nice question. As usual, we assume first term as A, common difference as D. So, and first term is given as 1. So, A is equal to 1. Common difference is D. And there are even number of terms. So, let the number of terms be 2n because it is even. That means you will have the series T1, T2, T3 and so on Tn up to nth term. After that Tn plus 1, Tn plus 2 and so on till T2n. There are 2n terms. What is the given condition? Ratio of the sum of the first 10 terms, this sum, and sum of the second half, this sum, are in a constant ratio. Then what is the common difference? Right. Now first I will find sum of the first half of the series. This is just usual AP, n by 2 into 2a, a is 1, so 2 plus n minus 1 into d, I do not know d, divided by sum of this. Here I do not have the first term, but I can calculate Tn plus 1 from here. This is starting from here, it is n plus 1th term. So applying the formula, a plus n plus 1 minus 1 into d. This is the first term of the second half. What is it? 1 plus nd. Alright. So again there are n terms in the second half also. So n by 2 into 2a for second half, this is the first term. So 2a means what is this? 1 plus nd, no? So 2 into this is first term for the second half. 2 times 1 plus nd plus number of terms is n. So it is n minus 1 into d. This is constant. Constant means what? It is independent of n and independent of d also, of course. That close. Let us cancel n by 2. What is the numerator? We can write this as 2 plus nd minus d by denominator 2 plus 2nd plus nd minus d is constant. Alright. Now numerator is 2 minus d plus nd upon denominator is again 2 minus d plus how much 3nd. Is constant, must be constant for what value of d? If you observe this, you can immediately tell the answer. For what value of d, this will become a constant independent of n and d. You can easily get the idea very quickly that d must be equal to 2. If d is equal to 2, what happens? This is 0. nd by 3nd, it is 1 by 3. Okay. So, this is constant for d is equal to 2. So, common difference of the AP must be 2. Alright. So, with this we have completed today's class, and in the next class I am going to discuss few more problems in AP, then immediately start GP. Alright. GP means geometric progression. That is the next topic, next class topic. Alright. Thank you very much for watching. So let us meet in the next class.